Hi, welcome to the video solution for Edexcel Physics past paper. This is IAL Physics Unit 3 Summer 2018. Let's start. Question number 1. Which of the following is an SI base quantity? Ampere, charge, current and volt. Of course, they are talking about base, so we cannot waste time over volt and the charge. Both are derived, not base. If you see, ampere is base unit while current is base quantity. So they are asking which one is base quantity, so option is C. And question number 2, in an experiment to determine the Planck constant, a student using light of a wavelength lambda 471 nanometer, which of the following is the correct value of lambda minus 1? So lambda minus 1 is basically 1 upon lambda, and if you do this, 1 upon 471 into 10 raised to the power minus 9, because of this nano is 10 to the power minus 9, and if you divide 1 upon 471, it will give you lambda inverse is equal to 2.12 10 to the power minus 3, and if this 10 to the power minus 9 you take it up in numerator, so according to arithmetic law of exponent, this 10 to the power minus 9 goes up and becomes 10 to the power plus 9. Clearly, if you simplify this, so you can find your option is D, 2.1 to 10, because 10 to the power minus 3, 9. So 2.12 into 10 to the power 6 meter inverse. So your option is D. So question number 1 C and 2 is D. Question number 3, 4 and 5 refer to an experiment to determine the resistivity of a material. A student has a sample of a material in the form of a wire with a diameter of about 1 millimeter. To determine the resistivity of the material, which of the following quantities would not be needed? So you need to look for the formula for resistivity. So resistivity rho is equal to R A by L. These are three quantity that you need. So you need length, you need area, and you need resistance. So density you don't need. So your option is A. Question number 4. A student has a sample of material wire. Okay, same question. Question number 4. Which of the following instrument should the student use to measure the diameter of a wire? Typical situation, typical question. Diameter of a wire is always use micrometer screw gauge. The best option is micrometer screw gauge. 5. Which of the following is the SI unit for resistivity? And if you see the formula, rho is equal to R A by L. So resistance is ohm, area is meter square, and length is meter, and 1 meter gets cancelled, so you have ohm meter. Option is C. Question number 6. An experiment report state that the mean diameter of a nylon thread is 0.150 millimeter plus minus 0.005 millimeter. State the range of the measurement. So range means you need to find maximum and minimum value, or you can say minimum or maximum value, and then you find the range by subtracting these values. So if you find the minimum value minimum value will be equal to 150 minus 0.005. It will give you 0.145 millimeter, and maximum value from this value is 150 plus 0.005, so 0.155 millimeter, and the range is difference of the two values. If you subtract these two, so you can find the range is 0.01 millimeter, and of course they have given the values till 3 decimal place. If you see 0.005, 3 dp, 3 decimal, so you must write 0.010 millimeter till 3 decimal places. Okay. Part B. Calculate the percentage uncertainty in the measurement of the diameter. So percentage uncertainty is you divide the uncertainty with the calculated or measured value. That means percentage uncertainty in the diameter is 0.005 divided by measured value 0.150 multiplied by 100. And if you solve this, the percentage uncertainty would be 3.3%. So this is percentage uncertainty in your measurement. C. The report states that the mean diameter of a human hair was measured as 0.075 millimeter with the percentage uncertainty of 5%. Calculate the uncertainty in the measurement of the diameter. Remember, in the formula of the percentage uncertainty, or if you see how do we find the percentage uncertainty? Uncertainty divided by the calculated value multiplied by 100. That means they have given you percentage uncertainty and the calculated value. So you can say that the percentage uncertainty, which is 0.5% divided by 100, so 0.05 equal uncertainty of in delta D divided by the diameter, which is 0.075. And if you find the delta D, which is the uncertainty in the diameter, will be 0.05 times 0.075, and it will give you 0.00375 millimeter. And of course you can say this is 3 decimal place, so you can round it off till 3 decimal place to 0.004 millimeter. This is uncertainty in the diameter of a human hair. Question number 7. A student is to determine the viscosity eta of a liquid using following steel spheres and a graphical method. The student has a measuring cylinder filled with a liquid and some steel spheres of different diameters. The terminal velocity v of the sphere falling through the liquid is given by v equal to, these are the some quantities involved in this equation, where r is the radius, rho s is the density, and rho l is the density of the liquid, where the values of both rho s and rho l are known. Write a plan for this experiment, and you should okay, so you should draw a label, you should draw and label a diagram showing how the sphere will be used. So it's all about finding the terminal velocity of a sphere falling through a liquid, and you have So you can draw these types of diagram, something like this, and this is a cylinder filled with some fluid of known density, something like this, and then you have a sphere falling down. You can take two marking like this and this, and then you put light gates here. These are the light gate, and you just label these. So you can say this is your cylinder, these are light gates, and this is fluid of known viscosity or known density, and this is a sphere. So this is a labeled diagram of the apparatus. Part B, list any additional measuring instrument required that are not shown in your diagram. If you recall the diagram, that I did not mention the meter rule in the diagram. So the additional measuring instrument we need to use is the meter rule, because its resolution is 0.1 centimeter and it is appropriate instrument to measure the distance between two mark on the cylinder. So additional instrument is meter rule. List the quantities to be measured. We are going to measure diameter of the sphere, and we are going to measure the time between two marks when the sphere is falling between two marks, and by dividing distance with the time we can find the velocity. So we need to measure diameter, time, and the distance for the velocity. For two quantities listed in C, explain your choice of measuring instrument. Of course, for diameter we are going to use micrometer screw gauge. It is because the resolution or precision of screw gauge is 0.001 centimeter, appropriate for these kinds of measurement. And for distance we are going to use meter rule to measure the distance between two marks. State which is the independent variable and which is the dependent variable. In this experiment, independent variable is the size of the sphere. In fact, we must say the diameter of the sphere is independent variable on which the terminal velocity depends. So independent variable is the diameter and dependent variable is velocity. For one quantity, comments on whether repeat readings are appropriate in this case. Indeed, in case of measuring diameter, repeated readings are good. We need to measure diameter at three different places or three different orientation, so that we can use mean value in order to get more accurate reading. So for diameter, yes, repeat reading is appropriate. Explain how the data collected will be used to determine the viscosity including a sketch of an expected graph. Okay, in this experiment we are measuring velocity against different size of the sphere. That means if you see the formula, formula involves V and R square. So we have we would have various readings of velocities corresponding of each radius. So we can plot the graph of V against R square, and we can expect a straight line. So this is a sketch of the graph. So we can expect a straight line from which we need to find the gradient, and the gradient will be V over R square. And if you see the formula in the previous page, formula for viscosity is eta is equal to 2 R square rho S minus rho L, this is L, into G divided by V. Now if you see R square over V, this is 1 upon gradient. So from this formula you can say that we can multiply twice of rho S minus rho L into G with 1 upon gradient that we found from the sketch or from the graph, that it will give us eta, the viscosity of the fluid. Identify the main sources of uncertainty and or systematic error. Sources of uncertainty is parallax error, because we are measuring distance with the help of a meter rule by naked eye, so we might have a parallax error in our measurement, and as we are using micrometer screw gauge, so we might have zero error in our screw gauge as a systematic error. Comment on safety. There is no such hazards in this experiment, but as we are using oil, so oil might spill on the ground, so we must have something to clean it quickly, because of to avoid floor slippery. So we can have a mop or something to clean the oil if it is spills. Question number 8. A student determined the acceleration of free fall g using a simple pendulum. The pendulum consists of a mass attached to a string which is suspended from a support as shown. Okay, so this is a pendulum swinging left or right between A and B string. The equation for a simple pendulum is T is equal to 2 pi root L over G, where T is the time taken for the mass to make one complete swing from A to B and back to A, and L is the length of the string. The student recorded the following result. So this is the length, 10 to the power minus 2 meter, time in second, T square and second square. Criticize these results. Typical question of criticizing the given table. Of course, very few reading, less number of reading, there is no repeat are shown, and if you see 0.8, 0.91, so one significant figure, two significant figure, three significant figures, so inconsistent use of significant figures. So these are most typical key points when you criticize some result. Explain why a graph of t square on the y-axis against L on the x-axis should be a straight line through the origin. Whenever these types of question comes, that if they say that the why do we have a graph of something as a straight line, that means we need to transform given equation in the form of y is equal to mx plus c. This is the typical technique that we use to show that the graph is a straight line. And the equation that is given in the previous page is t is equal to 2 pi L over G. And now if you see, they are saying we need to plot the graph between t square and L, while in the given equation we have a t and root of L. So we need to remove this root, so we can take a square on both sides. So we have a t square equal 4 pi square L upon G. And if you rearrange this equation like t square is equal to 4 pi square upon G into L, I rearrange the equation so that I have all the constant numbers in one place together and variables separate. So you can see that we can compare this equation with y equal mx, which is a straight line passing through origin with gradient m is equal to 4 pi square upon G. So you can say that this is the line passing through origin, with gradient m 4 pi square over G. Plot this graph on the grid provided and draw a line of best fit. So this is the table that was given to us in our previous pages. So we need to plot the graph between t square against L. So t square on the x-axis, L on the y-axis. So this is the length in 10 to the power minus 2 meter, and this is the t square, and these are the values. And if you can plot for corresponding points, so you can have these points for all from the table. So for 20 we have a 0.64, so 20.64, and 25 we have a 0.83, and then 30 we have 1, and then 35 we have a 1.10 around, and for 40 we have 1.3. And for the line of best fit, you need to draw a line that are passing through maximum point, or all the points are equally spread from the line. So I guess this is the line of best fit for me, because if you see that the first point and the last point are distant at either side. This point is further away, but this distance of these 2 points can be compensated with this single distance. That's how, or you can choose any other option, but I guess you know what is the meaning of line of best fit, which are at either passing through maximum points, or all the points are equally spaced or spread around the line. So this is line of best fit. Determine the gradient of the graph, and for gradient we need to choose 2 points, and after choosing 2 points, like we can choose any point, and we make sure that the triangles are as big as we can do. We can choose any point like this and this, and from these points we can form a triangle, and from this triangle we can find the gradient using rise over run. So gradient is y2 minus y1 over x2 minus x1. This is the idea of finding the gradient of a line. So let's see, these are the 2 points that I chose here, this, and from these I have these coordinates of these 2 points. So 22.5 and 0.71 is y coordinate, and so on. So I can say that the gradient of this line will be equal to, so gradient will be equal to 1.5 1.39 minus 0.71. So y2 minus y1. So 1.39 minus 0.71 divided by x2 minus x1. So 44.5 minus 22.5. And the gradient will be, yeah, there is one important point. Don't forget to put 10 to the power minus 2 in x coordinates. So this is into 10 to the power minus 2. When you find the gradient will give you 0.0309, or you can say that 10 to the power minus 2 and then 3.1. If you (3.1), this is time square, this is length, so s square meter minus 1. This is the gradient once you simplify this equation. So gradient is 3.1 second square meter minus 1. Use your value of the gradient to calculate the value of g. If you recall, gradient that we found from the equation m was 4 pi square over g. That means g should be 4 pi square into 1 upon m. That means 1 upon gradient. So value of g can be found using 4 into 3.14 square into 1 upon gradient. 1 upon gradient is 1 upon 3.1, which will give you 12.7 meter second minus 2. So this is the value of g calculated from the given data set. Calculate the percentage difference between the value of g calculated in CIII and the accepted value of g. So percentage difference. The percentage difference we can find using the approach of finding error or percentage difference, which is absolute values of you can say calculated value, standard value minus calculated value. Divided by a standard value times 100. We are using absolute value here, so you can replace calculated value minus a standard value, because we have to use always positive sign. In this case, you can see that we have 9.81 minus 12.7 absolute value divided by 9.81 into 100. That means percentage difference is 29.45%, or you round it off and you say that it is 29.5%. This is the percentage difference. Thank you very much for this paper. Have a nice time.